the function h of x is differentiable for all values of x. Okay? h of x equals h of 2 minus x, which is the following must be true. Okay. So I'm kind of used to seeing something like h of x equals h of negative x, which would mean that it's symmetrical about the y-axis. It's an even function. This has kind of the same form, but I'm not really sure what that means. So I'm just going to graph it out. You're like, what? We don't know anything about it. That's true. But that means we can be pretty generous on what we draw. So if we plug in, let's say, h of 0, that should equal h of 2. If we plug in 1, that'll be equal to h of 1. And what I'm doing is just plugging the numbers in there. H of 2 equals h of 0. Okay, which I already knew up there. And then, let's see, h of 3 would equal h of negative 1. So it looks like everything is symmetrical about x equals 1. So I have something like this. And then I'll just draw, I don't know, I can draw whatever I want. Like maybe like that, but then I'd have to draw like this. So it says that h of 0 equals h of 2. H of negative 1 is h of 3. Yep. And so it looks like this graph is just going to be symmetrical about the it's going to be symmetrical about x equals 1. Which of the following must be true? Okay? So this is the graph that we drew. We just drew something. That way it helps visualize. So we can update it as required. So this says 0 to 2, from 0 to 2 of h of x dx is greater than 0. Okay, in our graph, it is, but there's no reason for that to be true. We could take this graph and move it down like this. And we could even move it down further. So this isn't necessarily true because all we know about our graph here, ooh, could I group these together? And nope, maybe not, possibly, not sure. Group, haha, yes. So we can move it down like this. So then 0 to 2 would actually be less than 0. So that's not necessarily true. It wasn't the first graph that we drew, but not necessarily true. H prime of 1 equals 0. Well, it does look like that the derivative at that point is 0. If we draw the derivative, the tangent line, that's going to be 0. So that looks true. But we can maybe draw something that came together like this, where it's pointy. But we really can't do anything that's pointy because we were told that it's differentiable. So pointy means not differentiable. So the derivative at h of h prime of the derivative of h of 1, h prime of 1, derivative of h at 1 has to exist, which means it can't be pointy. So I don't think there's any way we could draw something that's symmetrical that doesn't have a flat surface, flat top like that. So yes, we could probably even look at this mathematically, which I assume, since it's a math test, that's what we should be doing in life. So if we take the derivative of both sides, we get h prime of x equals h prime of 2 minus x times the derivative of the interior, which would be negative 1, chain rule. We plug in 1, we get h prime of 1 equals h prime of 2 minus 1, which is 1, times negative 1. Cancel out the h primes, we get 0 equals negative 1. which is kind of a big hint there that we did something terribly wrong, because it's not true. Therefore, h prime of 1 would have to equal 0. Yes. I will say that one is true. Not only does it make sense, but mathematically. I wouldn't actually go through the math on the test. You just don't have enough time. But I would just do it through draw a graph, intuitive, the way it feels, and go with that. All right, h prime of 0 equals h prime of 2. So that's true. Equals 1. Not necessarily. Not necessarily. So here, just looking at our graph, that might not actually be true with the derivatives. So you look at our graph that we drew here, and we get like, this looks like that looks like about 1, based on just our random graph. But the h prime of 2 looks like negative 1. So that is, nope, h of 0 has to equal h of 2, but the derivative, h prime of 0, does not have to equal h prime of 2. It might, doesn't have to. So this one will be false. And especially there's no reason for us to believe that it would be 1. But 2 is correct. And so this would be our answer right there. Okay, this one is a bit challenging too. I wouldn't think about too much in terms of math. Again, you're given some data, you draw a graph, you adjust the graph based on each scenario you're given, and if you can make it work, it's probably true. If you can't make it work, then you have a counterexample to show that it's false. It's just much quicker to kind of, I hate to use the term, well, just wing it. But that's kind of what we're doing here. And you make a lot of assumptions. And the thing about assumptions is, when you make assumptions, you're usually correct. But sometimes you're wrong. And the goal here is not 100%. Get most things correct. Anyone can get 100% on these AP exams. Well, AP calculus exams. You just don't have time. Like, you don't have time to thoroughly work out these things. You're very restricted on how much time you have to do these problems. And so you do kind of have to haphazardly run your way through them. So this one, draw a picture, use the picture, learn as much as you can, go with your best guess. In this case, number 2 will be the answer. Thanks.